So opposite large A, the little side we call little a, lowercase a. Opposite large C, or capital C, is this side, and we call that lowercase c. Opposite big B, or angle B, is side AC, and we label that little b. This is the labeling conventions. So what should this side be called? F. Little f. What should the hypotenuse be called? Little d. What should this leg be called? Little e. Any questions so far? So now I want you to write all possible ratios of the sides of triangle ABC. How could we put A, B, and C in fraction form?
Is there going to be equivalence on it?
A over, no, we don't put it over itself. A over, okay, we're working only in ABC. A over B, what's another ratio we could write? A over C, what else could we do? We could do C over B, what else could we do? We could do B over A, what else? C over A and B over C. Okay? Those are all the possible ratios. How many are there? 6. Let's try it on this side. What are all the possible ratios over here? F over D, F over E, D over F, okay, E over F, E over D, and D over E. Notice I kind of wrote, do you see how these are reciprocals? All right. You know in a 30, 60, 90 triangle and 45, 45, 90 triangle, the sides had specific values of x? In our right triangle trig, if this is a 20-degree angle and this is a 70-degree angle, no matter how big or how long these sides of angle A get, the sides will always be in the same ratio. So it's like our 30, 60, 90 and 45, 45, 90, but after those two, then we're going to work with trig. All right. So now we're going to, what they've done is they have defined 3 trig ratios. One is called sine, one is called cosine, and one is called tangent. And all these are ratios. These are ratios, that means a fraction, of 2 sides of a triangle. There's actually 6. Remember how we got 6 on the other page? There's actually 6 of them. You're only responsible for 3 this year. What's this side called? Little a. What's this side called? Little b. What's this side called? Little c. All right. So sine. Maybe we should get out a sheet of paper. Want a foldable?
No. No, we just have notes and the video.
But it's so nice to pull the foldable out.
No, it's cool.
Okay. So that's sine. That's cosine. And that's tangent. That's the abbreviation. And sine of angle A, or sine of an angle, I don't want to specify any angle. I'm just going to put it this way. Sine of an angle, that's not L, that's an angle, is going to be opposite over hypotenuse. Okay, cosine of an angle is going to be the adjacent side. What does adjacent mean? If you lived in a house, an adjacent house to your friend, what does that mean? Next door. If your house was adjacent to your friend's house, your house is next door. Tan of an angle is going to be the side opposite over adjacent. Now you got to know this. Actually, this is on the reference sheet on your EOC. So there's this little mnemonic device called SOHCAHTOA. SOHCAHTOA. Sounds Indian. S stands for sine, C stands for cosine, and T stands for tangent. O stands for opposite, H stands for hypotenuse. So you see sine is opposite over hypotenuse. That's how they got so, except the H is silent. Then ka, A stands for adjacent, H stands for hypotenuse. Cosine is adjacent over hypotenuse. And toa, the toe, or the O, stands for opposite, and the A stands for adjacent. So that's a pretty cool mnemonic device to remember, as long as you remember that the H's are there. Or you could remember a sentence that silly old Harry caught a hog that Oliver ate.
How would Oliver do such a thing?
I don't know, but it fits with Toa. All right, so I'm going to bring this down, and these trig functions are very specific to the angle that is mentioned. So, because we're working with angle A, I'm going to highlight angle A. Now, with respect to angle A, who's opposite? Pardon? A, B, or C? A. A is opposite. With respect to angle A, who's adjacent? What is C? C is your hypotenuse. So who's adjacent to A? Okay, I understand why you said both of them now. C is special. It's a hypotenuse. So if I want sine A, then that's going to be opposite, which is little a, over hypotenuse, which is little c. If I want cosine of angle A, that's going to be adjacent, which is little b, over hypotenuse, which is little c. If I want tan, tan is going to be opposite, which is little a, over adjacent, which is little b. So one of the key things you have to be able to do for this unit is to be able to write those ratios.
I'm going to have like a mini quiz on this stuff.
Do you feel like you should have a mini quiz on this stuff?
Probably.
You think that would be a good grade? Okay, so now we're going to focus on B, and I'm going to go to a green pen, so green will match green. So with respect to angle B, who's opposite B? Little b. Now that's opposite. With respect to B, who's adjacent? A. All right? And the hypotenuse is always the hypotenuse. So if I want sine of angle B now, what is that going to be? Opposite. What's opposite? B over hypotenuse, which is what? C. If I want cosine of angle B, again, with respect to B, who's adjacent? A. Who's hypotenuse? C. If I want tangent of angle B, who's opposite? B, and who's adjacent? A. So it's all about the angle.
Is it always going to be lowercase?
We don't need this angle here. Is it always going to be lowercase for the these thingies, the ratios? Yes. All right. So remember, this is angle B, angle B, angle B. And notice, depending on your angle, the ratios are different. So look, cosine A is equal to sine B, because aren't those ratios the same? Interesting, isn't that? Well, I don't think I have I might have to get a graphing calculator. All right. I don't know what I meant to do here. Oh, this sine of angle A, and you know what? We don't put an angle. We just say sine A. I don't know why I put an angle there. I wasn't thinking. Sine A, it will be cosine B. You will not see the angle symbol, tan A. Oh, that should have been an A. All right, so what we want to do now is we want to use your calculator. Your calculator's there. Okay, I need you to do sine 42. Everybody do sine 42. Travis, what'd you get? Okay, there should be an SIN key on your calculator. You push it. Then you type in 42, and you hit equals. What did you get? 0.6691. That's what you got? Will you hit your mode key? Are you in radian or degree? Radian. That's why. Arrow over and get it into degree. Okay, so I want you to do cosine 14 with your calculator. Now you're going to hit the cosine key. Uh-huh. Who doesn't have one? Okay, so in order to do your homework, you're going to have to buy a new calculator. Sorry. One, 9. All right. All right, I need everybody to be able to do this. Are we doing well? What was cosine 14? Wait a minute, I heard 0.6, 902. I think you have to do 14. Type in 14, and now hit cosine. Okay, so if some of you, if you have an older TI, you're going to have to do the number and then hit the trig function. All right, let's do tan 125. What's tan 125? More. Give me like 4 places past the decimal.
Negative 1.428.
Okay, so when you are doing these, and especially those whose calculators work backwards, you need to use at least 4 decimal places past, or 4 numbers past the decimal. All right, so notice these were angles. You see the degrees? Those were angles. Now this sine inverse means that this is the ratio. In other words, this is the answer, and we want to go back to the angle. So in order to do this, I think you're going to have to push the second key, and then the sine key, and then type in your negative 0.4354. You might get a negative angle because I was just ignoring.
Negative 25.81.
Okay, did you do second sine? And did you do that? You got a syntax error?
The question's just too much.
Oh, you know what you probably did is you might have used the, how do you get out of there? You might have used the subtraction sign instead of the negative sign. If you get a syntax error, you use the subtraction sign instead of the negative sign, okay? The negative sign is there. Don't use the subtraction sign. Yes.
No, God.
You got syntax error, which means clear, which means you use the negative there. The negative always goes in front of the number. Okay, it doesn't go. Yes. Notice where I did it badly. Okay, so you all were typing in it just as I had it. It was really bad.
Is what his is, but there's no mode button.
Okay, this is a graphing calculator.
So is mine.
Right, you're not going to be able to use these
Why not?
because they don't allow them.
Okay, well, I'm using it.
So you have sign, so you're going to do second sign. You have to push the shift button.
Okay.
You're going to do, where's your sign? You're going to do second because, see, it's green. Sign. Okay, make sure. All right, this is bad. All right, this is bad. It should be negative 0.4354. That's why a lot of you are getting syntax error because I typed it wrong. All right, so now let's see if you can do cosine inverse. That means you push the second key, then you push cosine, then you type in this number. What do you get? 46.06. I will have you round to the tens place, so we'll say that's 46.1. Did everybody get that? You still getting syntax with no negatives? Show me.
This sign, I don't know. I don't know if I'm doing it.
Second sign. Negative 0.4354. Okay. You have to sign it out. You can't just take one, sir. Sydney? Yes. Pardon? No. How do you get to that? Oh. How do you get to that? I don't know how you get to that. But no, second is blue and it's going to go up there. I don't know. Unless you have a manual. Would you like to borrow mine? But that's Sydney's. Sydney, want to come get this? So Tommy, in order to do part of this homework, you're going to need a different calculator. Okay. All right. You want to still borrow it? Is it working? Okay, you can still borrow it. All right. So now we're going to, did anybody do tan? Anybody get tan? 51.8424. So because that's an angle.
There's no 8. It's 51.24.
Oh, 51 point.
2, 4.
Okay, so we're 51.2 if we round to the tens place. All right. So this is a prerequisite skill for what we're going to need to do. From here on, we're good to go. All right. So now we're going to solve the trigonometric equations, and that's our big push for today. Oh, I just got a circle. How did I do that? Okay, so I want to solve for x. How is 3 connected to x? Division, so I'm going to multiply both sides by 3. So those 3 cancel, so my x is going to equal 3 tan 42. What do you think you're going to do?
Huh?
What do you think you're going to do? So you're going to say 3 times tan button 42. Pardon? Okay, if it's backwards, for my backwards people, you're going to, Bree, do 42, hit the tan button. Okay? Give me 4, what 4 numbers past the decimal. What do you have?
0.004.
But there's nothing in front? Okay. If there's something in front, write that down and then go. Now you're going to have to do 3 times that. Okay? If your calculator does not work backwards, then you can do 3 tan 42, and what is that going to be? 2.7021.
70.
2 point.
70122.
Okay, that's good.
One. There's a one. There's another one.
I'm going to stop at the fourth place.
That's actually 5.
Okay. Next.
5 places.
All right. What do you think we're going to do here, Leslie? On this one. Multiply this side by and this side by 12, so they're gone. So that means y is equal to 12 sine 122.
It's 0.8480.
Wait a minute. Is that the answer? No. That's probably the sine 122.
Yeah.
If you have a calculator that doesn't work backwards, you can type in 12 times sine 122. What is it? Slow.
10.65.
Thank you. If your calculator works backwards, you do this first, 122 sine, write down at least 4 places past the decimal, and then multiply by 12. So how do we solve this one? Multiply each side by 10. So we've got 10 cosine 111 is equal to m. So what does m equal?
-3.
That's what I got. Thank you. Wait, is that wrong?
What'd you get?
Yeah, no. Oh, I used it. Sorry.
Okay. Are there any more decimal places after 5/8?
Yeah,
3/6. Okay. So, are we good on this? All right.
Oh, wait, no, it'd be 3/7 because there's 7 after.
Okay, so if we're going to round and round well, 7 causes a 6 to turn to 7.
Yeah.
Okay, so we're going to go to the next page. No, we're going to go back to this page. Because what would happen if I have sine 33 equals 5 over x? Now what happens? No.
Why would you
How do you eliminate this denominator? Multiply by x. So now we have x sine 33 is equal to what? 5. Now, how are you going to solve for x? Divide by sine 33.
Oh,
So, Bree, you're going to have to get this number 4 places past the decimal and then do 5 divided by that. So, if you have one that goes forward, you can do 5 divided by sine 33 and get the answer. Is yours a backwards one? But you need to be able to work with it tonight. That's my concern. Unless you go buy a new one. Okay? So what you're going to do is you're going to do 33 sine. Okay. So then you're going to, the 5 was already there. Then you're going to say 5 over, and you're going to do 0.5446. Now you're going to do 5, okay? 4 places past the decimal. Now you're going to do 5 divided by 5 divided by, Okay, no, we need 5 first. Oh, there you go. You got it. Yeah. I know, I wrote a new problem. We're not doing those. Okay, so now let's do tan 50 is equal to 8 over W. What do we have to do? How do we get rid of the denominator? If we're going to multiply this side by W, we multiply that side by W's. Well, next one. So we have W tan 50 is equal to 8. How do I disconnect tan and W? It's connected by multiply, so we will divide. So Bree, do you know how to use your calculator too? Okay, Bree, do 50 tan Okay, what's that number? Okay, so now you're going to do 8 divided by 1.1917. And you should get something close to this. Okay, so you're going to be a little bit off because they didn't round. They were able to use all their digits. And what we're going to do is I'm going to be having you round to the 10th place or the 100th place for your final answer. So we'll all match. Okay? So you know how to do this now, right? Use your calculator, because I hate for you to have to go out and buy a calculator if you don't need to. So what if we have cosine 93 is equal to 10 over m? That's your turn. You do it. Mm-hmm. I don't know what the answer is. Okay, hold on to that. Yes?
Found out how to do it. You just press it like twice.
Twice?
Yeah.
There you go. I'm so glad you figured it out. You type in the number with the trig function, the 33. Then you do sign button. No, wait a minute. I mean, how do you do that part? Is that what you're asking me?
Yeah.
Oh, you would do 5 and then divided by that number. All right, do you have it? You have it?
We're done.
I don't think Samantha's done. What did you do? You multiplied by m, right? Okay, you can't divide by 93. You've got to divide. This is what's being. This is this is attached. It would be like taking your arm off your body and giving it to someone. We can't do that. That's your arm, okay? So when you divide, you have to divide by this whole thing. Oh, you did it on that side. So that whole thing's gone. And what did you get? Yes.
I have a different number because mine works wrong.
Okay, yours is a backwards one.
Yeah.
What did you get? Okay, what did you get, Travis? Nice. Nice. What did you get? Good.
Why do you need to have that stuff?
For the people whose calculators work backwards. Ours, correct. You did nice. That's the correct answer. Okay, so where are you? Okay, so you have to get rid of this denominator first. It's being divided, you multiply. Okay? Now these are being multiplied. So you're going to have to divide by this to get m by itself. And when you divide by this, you divide that side by that also. Did you get it? I know you got it, or I think you got it. I know that Devin got it because he's the first one to show it to me. All right. Let's see. Okay. So how did, if this is being multiplied, how did it pop over on this side with multiply?
Because I divided the code 93.
Did you divide by cosine 93 since it's being multiplied? Wouldn't that be divided by cosine 93?
Yeah.
Okay. So did you get it? Yep, did you get it? All right. So now, did I miss you, Eric? Did you write it down? Okay. Do you have a pencil? Okay. So you did great here. You see how you did this? Now you've got to do it on this side too. Now you're going to do 10 divided by cosine 93. Okay, great. All right. Now, each one of these examples, you knew the angle, correct? Trevor? Each one of these examples, you knew the angle, correct? This is where we're headed next. What don't we know?
The answer.
We don't know the answer. All right. So what you're going to do, you know how addition undoes subtraction. Multiply undoes divide. Divide undoes multiply. Square root undoes a square. Squares undo square roots. Okay? So if we were to do tan inverse of this side, I'm going to rewrite it down here. If I do tan inverse of tan W,
Oh, that's tan.
that is, I'm fixing it. So tan W, and then we tan inverse this side. Okay, before we go any further, this is what I want you to do. Everybody have their calculator? I want to convince you first. I want you to do tan inverse of tan 3. Do tan inverse of tan 3. What is this?
3.
You sure? Everybody get 3?
Yeah.
Okay, now I want you to do sine inverse of sine 10. What do you get? 10. Now I want you to do cosine inverse of cosine 18. What do you get? 18. Okay, if you take the inverse function on the function, those simplify and leave you just what? W. Are you with me? Okay. Now, how do you do this side? Okay. So for my forwards people, Bree and Kayla, you're on hold right now. Okay? So I want you to do, you're going to do second, you're going to do tan, and then you're going to do 18 divided by 3. What do you get? 80.5376. All right. So, Kayla and Bree, you are going to do this first. Do 18 divided by 3 equals. Okay? And now I want you to hit second tan equals. You got it? See it? Okay, so let's go to this one. Here's my new one. Because H is attached to sine, how do I disconnect it? I'm going to do sine inverse of sine H. And that means I'm going to also do sine inverse of this side. See, it's real important that you show me this so that you know what buttons on your calculator to push. That sine stuff cancels, leaving me with just H. So second sine 11, yes, sir. Yes. Okay, on your homework, I want to see this work. What do you have? Are you going to use that calculator? Those will be available. 66 point. Okay. So, Bree and Kayla, you should have done 11 divided by 12. And then that would have been equals, and then sine inverse. Did you get the same thing? Okay. So if we look at this one, I've done a tan, I've done a sine, now we need to do a cosine. Again, you do this funky stuff when you don't know the angle. So what are we going to do? Cosine inverse of cosine G is equal to cosine inverse of negative 12 over 25. So that will simplify. What is G? What is it?
No, it's 61.31.
Wow.
It's 61.3146.
108 sounds better. 108 point.
118.
Oh, 118.
Oh, I didn't add the negative. That's my bad.
118. Okay.
Oh, gosh.
Oh, okay. You may pay attention to which key. This is yours all by yourself. I want to see the work. Write the equation. I want to see you doing the tan inverse.